All right, we're going to branch into a new topic for Chapter 17, and this is about solubility, how soluble something is in solution, a solid. So when you put different solids into solution, they're not all equally soluble, depending upon what it is. A simple example is like sugar and salt. One produces ions in solution, the other one doesn't, sugar, but they will have different masses that will dissolve in solution. For this conversation, we're pretty much going to be looking at just ionic type solutions, weak acids, bases, things like that. So let's go ahead and start off with a little example here. Again, the idea here is calculate solubility from, this is our last K value. We've had lots of different K values. This one is called Ksp, which in some books it's its own chapter based on solubility. Sp stands for solubility product constant. And of course, it's an equilibrium constant value at some temperature, which is almost always going to be 25 degrees Celsius. Okay, given, in this particular case, Ksp is equal to 3.9 times 10 to the negative 11. And the substance we're dealing with here is calcium fluoride. So we're going to go ahead and write out a rice table. So it works just like everything we've done previously in the last couple of chapters. So looking at a rice table, and it will be calcium fluoride. And this is a solid. And we're going to dissolve it and produce some calcium ions and some fluoride ions. And this is based on molarity, so moles per liter. Now, the fact that this is a solid, remember that in the Ksp or K expression, period, K, there are no solids because their concentrations are always 100%. So we don't actually include it. As long as it's present, that's the important thing. Having a volume of water, 1 liter, as long as it is present, that's all that's necessary. It could be just a little bit, or it could be like gobs. It's like a scientific word there, gobs. It doesn't really matter. So starting off, sitting here having some, I've just thrown it in, nothing's happened. This is initially, so nothing has gone into solution. But of course, it's going to change. And we're going to get some here, and based on the stoichiometry, twice as much is going to come from the fluoride ions. Now, this is interesting. We haven't actually dealt with coefficients in this expression yet. Everything has always been set up in such a way that it's just 1-to-1. So the first time we've actually seen this happen. So at equilibrium, we're going to have these amounts come into play. All right, so if we write a Ksp expression equilibrium, we are going to have products of reactants. So the products are calcium ions. Now this is important. When you're putting this part in here, don't put the two thing in here. The way we're looking at this isn't clear, is do not put 2F in here. It's just the fluoride concentration, period. The numbers will come in a second, but it's always based on the calcium concentration and the fluoride ion concentration. Now, what we don't ignore is the 2 here based on the expression, which we've done this back in chapter 15 and 16, where the 2 automatically does go up here. In other words, if someone told me that the concentration of fluoride is, I don't know, 1 times 10 to the negative 3, I would just put that number in here. I'm not going to manipulate it at all inside these brackets. I'm not going to say, oh, it's 1 times 10 to the negative 3, therefore it's 2 times, no, you don't do that. So whatever number comes in here, you automatically just put in here. So leave it as is. Now, that said, I don't know what it is, but I know there's a 2-to-1 relationship based on these two guys. I know this sounds like I'm contradicting myself, but try to distinguish the difference in what I'm saying. So you have the K value. There it is. I just pulled it out of the back of the book. This value here, again, I don't know what it is. This value, I also don't know what it is, but it is this. And I include this too. Now, this is something mathematically that always kind of bothered me, but it's applied differently, and that's okay. In other words, this 2 comes into play twice. It happens to be twice the value based on the stoich, and based on equilibrium, it also becomes the exponential factor. So it's kind of like you're double dipping. You kind of are. But just make sure you're clear on that. Also, please make sure that you are clear on your order of operations. This isn't this part of the math is done before this, so that please excuse my dear Aunt Sally, or please execute my dear, whichever way you learned it. You have to do this part here first, and then you can come back around. So just to briefly do this part here, looks like it's going to be 4x cubed. So again, square this and then multiply by x. Doing the rest of the math, so 3.9 times 10 to the negative 11 is equal to 4x cubed. I'm going to switch this around. X is equal to 2.14 times 10 to the negative 4, and these are molarities. These guys are always going to be molarities, so it is moles per liter. Done. There it is. So the solubility, that is what is equal to X, which is this, and they have a 1-to-1 relationship. So truly what I'm talking about here is calcium fluoride. It happens to be calcium as well, based on the stoichiometry. Okay, let's do another one. Calculate the solubility of lanthanum fluoride. This time the Ksp is equal to 2.1 times 10 to the negative 19. So that's really small. We'll breeze through this one a little more quickly. So there's my equation, or formula. It is a 3-to-1 relationship. I can ignore this. 0 to start with, goes up by x, goes up by 3x, and just becomes this. If I do the Ksp for this, again, it's going to be lanthanum and fluoride. And then based on the value from the back of the book, do the math here really quick. Well, I'll go ahead and put it in. X and 3x cubed is equal to 27x to the 4th, based on doing this part first. And I'm really quickly just going to go to the end and say x is equal to 9.3 times 10 to the negative 6. There we have it. All right, quickly, let's bounce over and do a problem in our homework. We are on number 51. So there it is, 51. #51 says, if the molar solubility of calcium fluoride at 35 degrees is that value, what is the Ksp at this temperature? So this one's asking us to go kind of in reverse from what we just did. So we're trying to figure out what the Ksp is, knowing the solubility, the solubility of calcium fluoride. So I'm going to write out this equation really quick. There it is. I'm going to write out the Ksp based on how these relate to each other. There it is. Now, based upon how these guys are relating, if I know that the calcium fluoride is this value, so let's just call that, for example, like x, this is x, and this is 2x. So you end up with x, 2x squared, and then therefore it would be 4x cubed. But again, I know what this value is, so I can go ahead and put that in for x and say that that is going to become, in this particular case, 4 times 1.24 times 10 to the negative 3 raised up to the third value. had to pause there for a second. So the last part of this, just to finish this off, so if we do the rest of this math that we had remaining there, it's simply going to be 7.63 times 10 to the negative 9. There it is. So that's just, again, just finishing off the rest of the math there. One thing you may notice, like, this looks really similar to a problem we just did, and we did. The only difference was we were at 35 degrees Celsius as opposed to 25 degrees Celsius, which is more standards, which is why we had a very specific number for part A. All right, I'm going to take a break here and we'll move on to part B on a new lecture.